This is a supplemental video for Chapter 3 in the book A+ Guide to Software, and in this chapter I focus mainly on working with disks. I felt that working with disks is very important, and Chapter 3 in our text just quite deliver the amount of material that I know we could work with. So some of our objectives are going to be working with different partitioning styles, NBR versus GPT, describing basic types of disks, describing dynamic types of disks and volumes, working with disk management, working with virtual hard disks, device drivers, device manager. We're going to end with partitions versus volume as a quick overview, and lastly, profile types and user management. So when we start asking the question, working with disks, what are some main items we have to discuss? First and foremost, partition style. That also could tie in with the different types of disk types, and then the division of partitions and or volumes. Lastly, what type of file system are we going to put on? So, working with the different types of partition styles. The big two within the Windows environment are MBR and GPT. GPT is GUID, or Global Unique Identifier Partition Table. MBR is Master Boot Record. This is how data is stored on the hard drive, the actual organization of the data on the hard drive. How we access, how we identify, how we coordinate the data on the drive. The main differences between partition styles is MBR can have 4 different types of groupings, or partitions/volumes. What I mean by that is we can break up a disk normally within 4 primary partitions, or 3 primary and 1 extended. I'm going to table the extended versus primary for a few slides, but the key thing here is you can group them up to 4 times, where in GPT you can group them up to 128 different times, and you can have larger disks. MBR normally supports up to 2 terabytes and slightly above that. The further you go above 2 terabytes, MBR starts getting worse and worse. But it's still capable of handling it, it's just no longer optimized. Where GPT, you can use 18 exabytes. So way more data than we currently have now. So let's talk about disk types. The 2 types of disks that we talk about are basic disks and dynamic disks. And a basic disk is compatible with older versions of Windows. It consists of primary and extended partitions. You can break it up into 4 different groups. And Windows typically is only installed on basic media storage. That's subjective, but I mean that's a generalization. So let's go back to that primary versus extended. What are the differences? Primary, they're separated. Primary can also host an operating system. You can mark it active, meaning you can boot from it. And you can format a partition that's designated primary to be a drive letter, D drive or E drive. You can group one physical disk multiple ways so that you can assign different letters to them. Versus extended. Extended cannot host an operating system. Extended cannot be active, meaning you can't boot from it. Basic disks can only host 1 extended but unlimited logical partitions, meaning the 4th group will be 1 large extended group, but inside of that you can start doing logical partitions. Do not format extended partitions. You actually just manage the individual local drives or logical partitions within that extended partition. So Within an extended partition, let's say you break up that fourth extended partition into 4 logical groups. You would manage each of those 4 logical groups individually. Extended and primary, kind of confusing. The big one is, can that host an operating system? Yes or no? That's the big area. Let's talk about disk types for dynamic disks. These are a combination of more than one disk. Pretty similar to hardware RAID, but on this way, we're doing this on software. When we talk about dynamic disks, we're actually talking about volumes. If the word volume is used, it's dynamic disks. If the word partition is used, it is going to be a partition. Basic disks are partition, dynamic disks are volumes. So with our dynamic disks, how many types are there? There are 4 major types: simple, spanned, striped, and mirrored. So again, very similar to the RAID functions. So simple volume is just one physical disk that could be separated. There's nothing special about this. It's just we segregated 2 logical disks out of one physical disk. We have one physical disk at 2 gigabytes, and we separated them into 2 1 gigabyte sections. The next is spanned volume, and that's where we're actually going to span the volume across more than 2 disks. This is going to be very similar to more like a RAID 5, but here there is no parity. That way you'd have data on more than one drive. The data will be written sequentially. Next is our striped, and that's where parts of the data is put on each drive equally spread out. So if there are 3 drives, a third of the data will be written to each drive. If one drive fails, you lose all the data. Next is a mirrored volume. We have 2 identical disks that are joined together to be exact identical copies. You'll notice here they are both E drive. They are 100% identical. That way, if one drive fails, the other one automatically kicks in and is 100% duplicate copy of the other. Alright, let's go ahead and move into our file systems. The big 4 that we deal with the most are NTFS, FAT, FAT32, and exFAT. exFAT is very common for flash drives. exFAT can go to most devices, a PlayStation, an Xbox, an Apple computer, or Windows PC. exFAT can go almost any device and be read to and written from. FAT and FAT32 are Windows specific. You still can do a FAT with some other devices. Like I have a FAT32 flash drive. I can stick it into my Apple PC and I can still write data to it. Not the best, but it's one of the big ones. Windows prefers NTFS. This is the preferred file system, handles large partitions, and introduces security. Security in the form of encryption and permissions per object. That way you can specify individual security options per object, per user, per group, per file, per folder. You have some control here. So keep in mind, these are only a few. These are the ones that are predominant in Windows. These are not the only file systems out there. Linux and Mac OS X use different file systems. So do keep that in mind. Disk management. It's one of the tools that allows you to manage individual disks. A disk could be optical, could be USB device, anything that does long-term storage, we can manage through disk management. And so what do we do with disk management? We can use it to do things like initialize disks, set up disks, selecting partition style, doing conversion from basic to dynamic. Once you go basic to dynamic, there is no reverse. Creating partitions and volumes, and my favorite, once you've predefined your groups, your partitions, you can actually then extend them, shrink them, and delete them. In our lab, you will see the issues with expanding and shrinking and the space issues. Using the disk management, you can also format partitions and volumes, assign letters to characters. You can change the drive letters. You can examine and manage individual physical disk properties, such as like quotas, sharing, and error checking. And keep in mind, this is going to be after hardware RAID has been completed. So this is assuming that the physical disk presented to Windows is a single disk. It doesn't always have to be. So let's move on to using some other disk tools. Things like disk cleanup, defragment disks, maybe checking the disk for errors. Those are some of the disk tools. So we talked about disk management. Is there a command line version of it? Sure. It's called Diskpart. And this is a straight CLI for managing your disks. You do not have to manage your disks through a GUI. Diskpart can do it through a command line. The big thing with disk management is it can do a lot, but it is limited. Diskpart, you can do many of the same tasks, but you can also do more tasks. Next, we're going to talk about working with virtual hard disks. In Windows 7 and above, you have these items called virtual hard disks. It is a logical hard disk that manifests itself as a file. Could be multiple files, could be a single file. You normally use virtual hard disks in Virtual PC or Windows Server's Hyper-V. If you're used to using VMware products, it's going to be the virtual hard disk for your VMware product. VHDs, it's a file format, contains the entire contents of a hard disk. It's used to store the hard drive of a VM. It can be created with disk management, so you can actually create additional virtual disks. You can boot off of a VHD as well in certain versions of Windows 7 and above. So VHDs can do several nifty things. Other uses of your VHDs could be moving files, backing up, checking antivirus and or security, maybe also do image management and patching. You want to prep a hard disk so that it has everything that one is going to need. Just some options. The booting option we talked about, or native boot, and it's supported in Windows 7 Enterprise, Ultimate, and all versions of Server 2008 and above. It allows you to create the VHDs and boot Windows 7 from a VHD. The big thing here is not having to worry about a virtual hard disk manager. You can just do it from Windows 7 Disk Management or Diskpart. Some of the advantages could be offline image updates, could be better format for imaging, for deployment and testing. A big part of this is you're going to notice that VHDs are really good for handling images and or clones. So how do we attach and detach VHDs? In disk management, it's actually one of the options. You can attach or move or mount or demount these virtual disks. You give it the location of the VHD, and you can mount it. Mounting is just a clever way of saying attach it or use it. When you're done using it, you can demount it. That is, detach it. You cannot detach a VHD or a file if it's in use. So that's a huge concept. If the file is in use, it's mounted. It's being used. If you want to demount it or detach it, you have to stop accessing it. How to boot from a VHD? You have to give it the boot command so that the BCD recognizes that it will boot from a VHD. Here's an example. You could edit the BCD by BCDedit. You can copy the information you need. That way, next time it boots, it will boot off of the VHD. It's not always as straightforward as this, but essentially you'd be doing BCDedit and you'd be setting the device equal to the VHD. So let's go and move on to working with devices and drivers. What is the device driver? A device driver is software that provides the OS with information and the ability to communicate with individual devices. They vary in complexity. For example, a USB mouse. A simple 3-button mouse may have very simplistic drivers, but a 20-button USB mouse may have more complex drivers. But it's all about being able to use the device you have. So that's a key thing. So how can we verify that the drivers that we're getting are legit? We have these things called signed drivers, and that's an assurance from the publisher that they have not been altered and that they will work. That way, if you buy a $100 keyboard and you want to make sure 100% that it's going to work, you can check the signed drivers to verify that the manufacturer of the keyboard has actually published those drivers and that they are legit. Not that many organizations do put malware in their driver packages. It's just the idea that it can be done. You are starting to see more and more issue with driver packages not truly just being drivers anymore. Creating a driver update policy, this is a big one, especially for organizations. It talks about how we're going to get drivers from hardware manufacturers so that we can address key issues, implement better features, and improve performance. On keyboard and mice, not that big of a deal, but when we start talking about drivers for video, drivers for audio, some organizations, that's a lot of money. If you deal with 3D rendering, having a video card that can handle that more efficiently, that could be a huge thing. Driver signing. Without driver signing, we don't know who actually published the driver. And that was the one big thing that I wanted to drill, was we don't know who actually created the drivers. We don't know if the drivers were altered. Windows can now install those drivers. It was just in Vista and early 7, understanding the driver signatures were important because you used to have them. Now, that's no longer the case. So you may have to supply drivers during Windows installation. That way, Windows will get better communication with devices functioning. That may or may not always be the case. Windows 7, 8, 8.1, 10 all provide generic drivers for most items when it's installed. That's without issue. What happens if we get a new computer and we have hardware and we're not sure if they're going to work. That Windows has a hardware quality labs test, and that is called WHQL, and that's essentially just guaranteeing that a specific piece of hardware will work with a specific type of software. And you can actually couple this with Windows updates so that they'll detect what type of hardware you have, and it will only update with qualified software. You can do that manually or automatically. That way, as let's say video drivers are installed or released, Windows updates will automatically install them only after they've passed the HWQL tests. Using Device Manager. So what is Device Manager? Device Manager is a tool that we can use for troubleshooting and seeing known issues and hardware devices. This is also where we install, update, and roll back drivers. This is what it looks like. You will actually see it broken down into different groups. You can drill down specific groups like display adapter. That will list the display adapters for that computer. You can then update or do items that you need. Here we also see ports. Underneath ports you can see COM port 1. And we can actually look at the properties for COM port 1. We get a Generals tab, port settings, drivers, what resources they use, if it's working correctly or not. The big one is drivers, because you can update, install, or roll back to a previous driver if need be from here. From here you can also troubleshoot drivers, because with drivers there is a troubleshooter within the properties setting. You can always remove a driver, update or install new ones, or if there is a problem, you can always roll back a driver. So let's get back into our disks, partitions, and volumes. We're almost done. We only have to worry about describing partitions and volumes, a brief overview, and then to our profiles and users. So partitions versus volume. Partition is used to describe reserved regions of a space on a basic disk. Volume is used to describe regions of a reserved space on a dynamic disk. Windows 7 can be installed on either, but it used to only be installed in basic. Other types of differences between dynamic and basic is primary versus extended versus logical, and then the dynamic disk type: simple, span, striped, mirrored, or RAID. This is a good chart to know. Basic disk rules. Here's a brief overview of the disk rules again. Primary or extended partitions. Note the definition. Big thing here is primary. You can have 3 primary, 1 extended. Primary can host an operating system. Here are the volume types. Again, simple, span, striped, mirrored, and RAID 5. Again, really good to know. So let's go ahead and talk about file systems one more time, but this in terms of managing. So which ones do Windows 7 support? Windows 7 supports FAT and TFS, UDF, CDF, and exFAT. UFF and CDFS are the CD and DVD file systems. So let's talk about NTFS and previous copies. What's that about? We have previous versions, and they're saved as shadow copies. And copies are a system in which the computer will take a snapshot of a file at a specific point in time, so we can track changes back to that snapshot. There's a backup copy and a shadow copy. A backup copy is created with Windows Backup. Shadow copies are created as part of the volume restore points. And that's a good amount of detail about our disks. So the last thing we have to discuss, users and profiles. User management. There are 3 general types of users: administrator, standard, and guest. An administrator has top-level access. They can do everything. Standard, they can do basic tasks that only affect themselves, not the computer as a whole. An administrator can do everything on a system regardless of who it affects. A standard user, normally you can save data. With a guest account, you can log in as a guest, you have limited access, and nothing is saved. Those are 3 general types of users. That is not groups. These are individual accounts. Let's go ahead and move on to our different user profiles. User profiles in Windows Vista and above, so 7, 8, 8.1, 10, everything is stored in the users folder underneath C drive. And there are 4 profile types that are generally supported: the default profile, a roaming profile, mandatory profile, and the public profile. But what are these profile types? A default profile is used when a user profile is created. It's just a typical general profile. But what happens if you want user data to go with you as you change computers? Normally that's classified as a roaming profile, and it is stored not on the individual computer but on a network server, thus allowing users to access their profile as they move from computer to computer. Their data will go with them. Next, mandatory profile. These are profiles that cannot be modified. Users can make changes to their desktop settings while they're logged on, but nothing is saved. Lastly is this public profile, and that is a public profile. It's not a full profile. It doesn't include the ntuser.dat, which means it does not include any registry settings, and it's just a series of folders. This is just a very bare minimum. Nothing gets saved, nothing to really be worked on or done. It's just mainly for a guest user. Lastly is managing groups. There are 2 major types of groups: built-in groups and specialty groups. But you may have a 3rd group, which is a customized group depending on your needs. For example, Windows 7 includes local built-in groups like administrators. The administrator is actually a user in the administrator's group. You can actually add in a standard user to the administrator's group and then become an administrator. You can also do things like a backup operator. You can assign them specific groups to accomplish tasks. Like backup operator, they can run backups. They may not be able to view backups, but they can run backups. So you can tweak groups and group membership to do specific tasks. The last one, which is always my favorite, parental controls. In Vista and above, you can have a parent account and children account, and you can control different access and restrictions to children accounts. Like you can say children are allowed to access the computer from A to B time. Children are allowed to play X-rated game. You can set the restrictions so that their account is very limited. That's actually it for our supplemental chapter. I wanted to thank you guys, and I hope you guys have a great day. Thank you.